So our next speaker is representing the year 2020, though he also spoke in 16, 17, 18, and 21. In fact, I first met him at the very first R conference at the bar afterwards at Rye House, where so many of our hours were spent as part of this meetup group in this conference, which sadly no longer exists. But there's a new bar there, which is okay. But I met him there. I'm like, oh, you're going to speak next year. And he said, sure. And then he spoke many, many years. But neither he nor his wife have ever learned to drive. And when he was on vacation recently, he got behind the wheel of a golf cart, and his son says to him, Daddy, you can't drive. So it sounds like they survived, though. So, D-Rob.
Thanks, Jared. I'm really excited to be here. I was especially excited to see today's agenda because actually a couple hours ago, Sean Taylor presented on a really similar topic, the analysis of event sequence data. You might be surprised that two people talked about that same topic in the same conference. I'm surprised that it was only two. I'm surprised there aren't half a dozen talks about the analysis of product data and event sequences because I think it's a very important topic, and I'll tell you why. So when a company designs a product, they want it to be easy to use. And it's very possible to get that wrong. It's possible to build a product that maybe aesthetically makes sense to people that built it, but as soon as you start trying to use it, it doesn't work. This happens with physical products. And the problem with physical products is if it happens, you don't really get data about it. Maybe you can try and send out a survey, maybe you get complaints, but you don't realize the struggles people are having while they're using your physical products. But digital products have an amazing advantage. They collect data on how every single customer is using the product. The average website you're visiting, every page view, every click is being stored as telemetry in their analytics system. So you're actually able to see every page you view, where you get stuck, what steps that are causing you problems. Also, they can streamline that flow. So my question is, what's their excuse? Why are there so many websites that are so impossible to use? Why are there so many forms or trying to navigate through them? You have to go back to previous steps and get arcane error messages. Why are so many navigation systems overwhelming? We could say the companies don't care, but that's clearly not true. They have a vested interest in making this flow of bringing you to a purchase easier. My hypothesis is that this is a scientific problem. Fundamentally, we haven't invested in statistical tools to take sequence events, turn them into product insights and improvements. So excited to see Sean Taylor say the same thing a couple hours ago in his talk. I think it's a problem that the field really is waking up to. As we start collecting this new type of data, we're really kind of missing a theoretical foundation for how we go about taking this, turning it into useful insights to help make web pages better. So I'm going to talk about theoretical and mathematical and product work that we did at Heap, which has since been acquired by Contentsquare, to power Journey's product. So everything I'm talking about is a product that you can buy and use. Definitely check it out. I'm mostly not going to be focusing on the product itself, but rather the mathematical ideas behind it. I think it can be useful to everyone, whether or not you're a customer. I'm really going to be focusing on this theory, this missing science that I see of analyzing and improving products. I wish I could have taken courses in school. We talk about how to analyze sequence events. I wish there were textbooks we could read on the topic. And I think we're just getting started. So to start with an approach that might be tempting, we take all this data, let's try doing some correlations. Let's try taking all these sequences, all the clicks and views and things that people do, and let's try counting them. That's great. We're statisticians. We love matrices. We want to take this binary count matrix of one row for every user, one column for every page view or click that a user does. And we want to use that to, let's say, we're an e-commerce product. We want to predict which of them led to purchases. So really, it's a statistical machine learning problem. It's something that we have a lot of tools in our toolbox to use, right? So we might as well try it. We take all these clicks and we apply a predictive model. And we discover that the number one thing that predicts purchase is this button. So we go to the product manager, we said, why don't you make that button bigger? And we say, okay, well, hold on, that might not be what we were looking for. Let's filter that one out. It's super obvious. Let's look for the next one. And the second biggest correlation is with this button, a 99% correlation with purchasing. And we could just keep going down the line and kind of walking our way backwards in the flow, but I would say let's stop and think for a second of what we're doing when we try and predict. Fundamentally, the problem that we're being asked to solve is not predictive. It's not something that can be solved by machine learning. It's causal. It's a question about an intervention. Product designers and owners want to know what change can they make to their product, what step can they make easier, what flow should they fix or replace that will cause a change in the behavior of users on their website that will make it more likely to lead to purchase, more likely to lead to retention. Fundamentally, we need to be using the language and theory of causal reasoning. So I made the joke earlier of, oh, maybe let's just make the purchase button bigger. But the truth is, it might be possible the purchase button is too small. If we did want to determine that, there's a standard way to do so in the field, and that's an A/B test. We say to designers, you know what, the purchase button is too small. Let's randomly allocate every user to either a control or an experiment with a larger purchase button, and let's say, and then we use that to see, okay, does the purchase rate go up? And that is really effective at determining the causal impact of an intervention. And it's no surprise it is, because we've been studying this for a century. It's randomized controlled trials. It's something that product builders have really borrowed from the field of science and statistics to very mature conceptual technology. But it's not the only way to reason about causal effects. It doesn't mean that all observational data is useless. Imagine where medicine would have gotten if all we had were randomized controlled trials. We didn't have microscopes, we didn't have anatomy, we didn't have dissections, we didn't have the germ theory of disease. The only thing we could do is give pills and find out whether or not they work. So just because randomized tests are the gold standard doesn't mean that's where we have to begin and end when we're looking at causal interventions. So I'm going to talk, A/B tests are a technology that works really extremely well for recognizing causation, but they're very expensive. They can't be done retroactively. So I'm going to talk about a technology that actually does work. This is, I think, one of the few product analytics paradigms, theoretical ideas that has been around a while and does work really well, which is, I don't want to run a new experiment. I just want to know, is it true that my purchase button, if I made it bigger, I'd get more purchases? Well, maybe what I do is I split it up into steps. I say, let's take everything up until to just a step before the purchase button and then the purchase. And then I ask, how many users reached each of these steps? We see how many started, how many reached the next step of those, how many reached the subsequent step, and we turned those into percentages. Here's a question for everyone. Do we think making the purchase button bigger will help increase the number of purchases? No. Intuitively, all could tell why, which is, no, it really does. It looks like almost all the drop-off happened to the previous step. In fact, we might break it down even a little bit further, create a multi-step funnel where we say most users made it to the first step, a lot of users lost the next step, and then almost everyone made it through this last step. And we might draw from this conclusion, our best opportunity is here. You didn't do any math to figure this out, and you didn't look at any data that wasn't on the screen, but it felt intuitively obvious to you. And let's start to think for a second about why is that true? Why did this work as a causal technology, these funnels, the step of saying, okay, break it up into steps and see which steps have high conversion rates, which have low ones? Why does that work? I think the reason is two principles we're using. Locality, we're assuming modifications to one part of a flow affect only that step in the funnel. It's not always true. Maybe the purchase button is so ugly, people turn it off as soon as they jump on the page, but it's an assumption that's pretty safe. A second is chronology. Users are measured when they progress forward in the funnel. This is something really worth thinking about, is that if a user skipped all the way to the purchase step, they wouldn't have been counted in that funnel at all. They would have been counted as if they dropped off at the first step. That's actually a necessary part of how we measure funnels, because it's the thing that gives them their characteristic funnel shape. If you were able to jump to any step and you just said, let's just count how many users did every step on this page, you get some things that were done a lot, some things that were done a little, but you wouldn't be able to reason about here's the step where we're losing people. And that's very powerful, but very limited, because the weakness of a funnel is that it's linear. A funnel measures this step to this step to this step, and once a user does that step, it'll allow them to progress. What the user really did might have been a lot of things in between. They might have skipped a step, come back to it, backtracked. And a funnel actually, it's not just that it's difficult to measure that with a funnel. It's actually mathematically impossible to measure certain behaviors, even if you use multiple funnels and try and compare them. I'll leave that as an exercise to the reader, but I find it a very interesting fact that funnels are so powerful, but can't really solve this problem of nonlinear optional backtracking, skipping user behavior. So there have been a lot of tools out there for measuring these kinds of nonlinear sequence, a lot of them built over the last decade and a half of product analytics. Sean talked about them some earlier as well. And one thing a lot of them have in common is they count consecutive actions. They're looking at user did this, then what is the next thing they did, then what is the next thing they did. And a problem that Sean talked about as well is that there's an explosion in state space. Every user who purchased on their 6th click is treated completely differently from users purchased on their 5th click or their 7th click. So you really have to start finding ways to aggregate these trees and break them down, and that's actually really not conducive to trying to draw conclusions. It's hard to say, if you went into this step, this one part of the flow, and you made a change there, how will it affect the overall conversion? Well, that one step might actually be represented dozens of times on these sequence maps. So I'm going to introduce a new mathematical and conceptual technology, which I call which we at Heap that developed it call journeygrams. So journeygrams are a calculus for using a directed rooted tree to quantify sequences of events. Now, in some ways, that's similar to the product analytics tools we were seeing a second ago, but there are two important differences. One is we're specifying the tree based on the causal hypotheses we're considering. Something we learned from causal inference is that data are profoundly dumb about their causes. It's not something you can automatically have a machine look at and say, oh yes, this is the tree you want to build. There are some ways we can really help you along, but ultimately it's the user that brings their understanding when they build this journey. We then set up rules for quantifying these sequences with this journey. I'm not going to walk through them in detail. But the really important one is that we're ignoring any step that we're not waiting for. So this is a journey that's meant to represent a split between B1 and B2, and anything else that happens at that step, we're actually just ignoring. We're not going to progress. We're not going to count them in that direction. And that makes it a very powerful lens on which to start looking at a variety of nonlinear behaviors. Those funnels we discussed earlier, the reason they're useful is that they're a special case of this type of technology. They're one where you have what's called a path graph, a pathological case of a tree, and we can and from that we can say, okay, here's where drop-off happened. But we could also represent forks. We can represent actions that some users do, others don't. We can represent backtracking, all as different trees. If we want to investigate one of these behaviors, we create one of these trees to quantify it. And that's really so I'll show how we're gonna use that to analyze a particular question. Let's go back to this checkout page. Now we can't just say, this button is good, this button is bad, this purchase button is very useful at getting into purchases, but we can compare ones that happen at the same point in a journey. If we just make a couple of assumptions, but at least we're really controlling for one step, which is how far did you make it through this flow? So we start by creating a fork. We say, if you started the form, how many users did these 3 actions? And we do that because we have an understanding that these 3 users that reach these 3 points, at the moment they reach those points, are pretty comparable. And then we ask, okay, from each of these actions, if we want to say, if you picked this, if you picked this, if you picked this, what was your ultimate purchase rate? One important thing here, as I noted earlier, is that these aren't necessarily consecutive. These aren't saying, is the next thing you did purchase with nothing in between. This is saying, did you eventually, maybe you did a couple of things in the way, did you eventually end up purchasing? And from a journey like this, we can draw a lot of conclusions. For the mathematical approach we're taking is matching, so they call it in causal inference. We're saying when the moment a user reaches this point, they're comparable. And then we're able to say, okay, well, if they're comparable, I'm able to say this flow has a lot of friction. I'm able to compare it to another one and say, wow, if PayPal were as easy to use as Apple Pay, then we hypothesized we could get this conversion rate up to 90%. And a third step, we're able to say we can set a bound on the impact we'd have if we improve it. We can say, okay, but not a lot of users are clicking this button at all. Those are the only users that are being exposed to this intervention we're taking. So the journey lets us both estimate the impact of an intervention and the exposure of it. These kind of forks show up everywhere in a digital product. Anytime we can say there are 2 ways to do something, 3 ways to do something, 4 ways to do something, we can start building these forks and saying, if of these things that a user might do at the same moment in their journey, how can we compare them? How can we discover, let's say, which of these routes is more successful? And are we pushing enough users in that direction? Are there ways we could make design changes to get users from some of these other buttons to this path that's more successful? That's a lot more plausible than just make the purchase button bigger. Journeys can do even richer analyses when we start thinking not just in terms of forks, but steps that maybe get skipped or are optional. So sometimes skipping a step is good, it's less friction. Sometimes skipping a step is really bad. Let's take a case of some really bad UI. This is based on a real customer interview and deep dive that we did to try looking at the how we might analyze this, where there was a terms and conditions that was buried in the middle of a couple of other checkboxes and really wasn't well emphasized. So you might really ignore it. Maybe it has a bad color. It's really easy to miss it. And if you try purchasing, maybe what you get is just a generic error message that actually doesn't tell you, here's what you need to do to here's what you need to do to fix the problem. Here's and what you're left doing is really they're left hunting around. So now, if we see that issue, and we're going to ask, okay, is this an important problem? How much could we improve the purchase rate if we fixed it? So we build a journey that says users start, they either click terms and conditions, or they go straight to purchase. And this way, you're actually comparing 2 groups. You're doing matching of saying there's a group that did click terms and condition, a group that didn't. It's possible, let's say that these groups are really similar in terms of certainly they've expressed an intention to purchase, and then we ask, okay, after that, did they have a successful purchase? And if we fill it in with some data, we might say, okay, a lot of users actually missed the terms and conditions. In fact, more users missed it their first time than clicked it. Now, after they missed it, a lot of them still figured it out and had a successful purchase, but not all of them. And not as many as people that had succeeded in clicking this button. Maybe that was 98%. Maybe there was some other problem that for those 2% of users that didn't make it. And that lets us compute an opportunity size. Let's do these comparison. And this is the kind of technology the kind of insight you never could have gotten from a bag of clicks approach. I don't mean it would have been difficult or required a lot of computing power or data. I mean the data actually got lost at this point because it's exclusively about chronology. It's not about correlation because the terms and conditions box actually has exactly the same correlation with the end desire, whether or not there is this problem. The problem isn't the users that users do it are more likely to complete. The problem is when users do it, if they're able to do it, remember to do it before they click purchase. I think of one other area where examining and quantifying user journeys can be really powerful in product analytics, and that's in retention. Sometimes the goal is not necessarily drive purchases right now, but try driving long-term behaviors. So, for example, saying on a SaaS product or consumer product is saying, I want to get people coming back in the long term. If you've heard of Facebook's aha moment, where they say you want to get 7 friends in 10 days because their data scientists found that if you had made 7 friends in your first 10 days, you were more likely to return. And the theory is that's an aha moment. And I'm sure the data scientists that built this were really capable, and I'm sure they're right that they did some graph like this that says if you make 7 friends in 10 days, you'll have a much higher probability of retention. But I bet you this graph is true too. If you graph number of friend requests rejected in your first 10 days, then your probability of retention will go up with that as well. In fact, it'll go up a lot faster. And the reason, of course, is that to get friend requests rejected, you need to be making friend requests. In fact, people that get a lot of friend requests rejected probably did a lot of friending. Early on, at every stage of product lifecycle, everything is correlated, every action you're doing in the product. Sometimes people say, we found that this click was correlated with people coming back. I say, take a look at whether errors are correlated with people coming back. If you look at how many errors a user ran into in their first week, I bet you there's a pretty good correlation with coming back, simply because it's downstream of the confounder of how much behavior they actually did on the site. So what I'd rather know is, rather than a statistic like this for an aha moment, I'd rather find two actions that represent the same moment in a journey, something that a new user might do in their first day, and compare, just from that small action, what was the difference in their long-term retention rate. So then if we can set it up so that these two groups are comparable, which is not easy and does require some thinking about an understanding of the product, we can say, let's say that, many users are starting by following a celebrity, but that doesn't lead to long-term retention. But sending a friend request does, and there are product interventions we can make in that direction. So John Pierce, who helped develop the initial computers, had this saying I like, which is, after growing wildly for years, the field of computing appears to be reaching its infancy. I feel the same way about the field of product science, the ability to take this event stream data and turn it into actual insight. I feel like we're at this point in a curve where we can say, oh, it's so interesting that both Sean Taylor and Dave Robinson are talking about analyzing event data. I think that's because we're just starting to get it right. And if there's one call to action, I do hope some folks check out HEAP, but I really hope folks start studying this topic. If you're a PhD student or an academic, I would really love to read papers on this. I'd love to see studies of this. I think it's a really exciting area, and I'm really glad to be here for the early stages of it. Thank you.